The last shape we're going to learn the volume of for a while is the sphere. And the sphere definitely has the weirdest formula when compared to the cylinder and the cone. Cylinder and cone had formulas that were almost identical. They both used pi r squared times h. The only difference was that the cone had the 1/3 added into it. Well, the sphere uses pi and it uses the radius, but that's kind of where the similarities end. The volume for the sphere is pretty weird. It's a pretty weird formula. It is 4/3 pi r cubed. 4/3 pi r cubed is the formula we will be using for the sphere. Now, it is a weird formula. 4/3 is kind of unusual. It's the first time we've had a formula with cubed in it, so that's kind of unusual. But the good news is the sphere only has one measurement. We don't have to worry about height this time because sphere doesn't have height, or I guess it does have height, but it's just the diameter. We've only got that one measurement. It's the radius. So once you know the radius, you're done. So there's your silver lining there. So we're going to find the volume of each one of these spheres. As usual, we will be using 3.14 for pi, and the problem does tell us to round our answers to the nearest tenth. So good news, the first one just gives us the radius, 2.1. So all we have to do is take our volume formula and substitute our 3.14 for pi and our 2.1 for the radius. Okay, so let's do 2.1, and we're going to raise it to the third power. This is where a calculator that can do fractions really shines because you can just put in the 4/3. If you try to do 4 divided by 3, you'll get 1.333333, which is a pretty unfortunate thing to try to put into a calculator. So if you have a calculator that's not so great with the fractions, you can, of course, put it in the calculator by opening parentheses, doing 4 divided by 3, and then closing parentheses. It doesn't look the best, but it gets the job done. That's what my wife tells people about me. Times 3.14 for pi, and then times 2.1, and then this time we're not going to square it. We're going to raise it to the third power. It's 2.1 cubed, so make sure you get that third for the exponent there. And we come out with 38.77272, which is not my favorite number. Whoops, definitely don't want to write my answer in highlighter. 38.77272, but the problem does say round to the nearest tenth, so 38.77 is going to round to 38.8. The unit that we're measuring with here is centimeters, and because this is volume, it is going to be cubic centimeters, and there's our answer, 38.8 cubic centimeters. The only time these problems are going to get tricky outside of just putting this nastiness into the calculator is just like with our cones and cylinders, if it gives us the diameter instead of the radius. And I'm using the word tricky a little loosely here because as long as you recognize, oh, hey, that's the entire way across the sphere instead of just halfway, it's not that bad. We just take whatever the diameter is and divide by 2. 7 divided by 2 is 3.5. And now we just start plugging things in. Volume equals 4/3 pi r cubed. So here we go. 4/3, so open parentheses, 4 divided by 3, close parentheses. Oh, my kingdom for a TI-84. It would look so much nicer. 3.5 cubed. 4 thirds times 3.14 times the radius cubed, which in this case is 3.5 cubed. Our answer is, oh my gosh. Now that is an answer only a mother could love. 5, 0, and then a whole bunch of threes. Luckily, we're not going to have to deal with all that because it says round to the nearest tenth. And luckily, rounding 0.50 is pretty easy. It's going to be 179.5 cubic centimeters. Oh, whoops. I forgot to do my approximately here. If you're wondering why I'm not doing approximately on the answer, it's because the problem tells me to round the answer. So I'm giving the problem exactly what it wants. It wants 179.5, but I want to put approximately on what I'm writing from the calculator because I'm not writing exactly what the calculator's telling me. So 179.5 cubic centimeters is the volume of that sphere. So I don't think the math associated with spheres is particularly difficult. The formula is a little weird. That 4 thirds is kind of an uncomfortable thing to use, and cubed is something new to us. We're still just plugging it into the calculator though to get our final answer. So as long as you're reasonably comfortable with the calculator, and as long as you're good with rounding, because we're usually going to round our answers because they're when you multiply by 4 thirds and pi, your answers are not going to be pretty. So we're going to round usually. As long as you're good with that, you should be fine with volume of spheres.